you. Yeah, hi everybody. I admire your stamina. You've got another 2 sessions after this one, right? So I better keep to time. So my name is Simon Field. I'm our field CTO for EMEA, which is a bit of a mouthful. I work in a team within Snowflake that's the customer-facing part of our product organization. So working with large clients, understanding their challenges, feeding that back into our product organization, working with new aspects of the product and helping customers to start using that and again, getting feedback on that. So today, what I'd like to talk to you about is using your data warehouse for data science. Maybe a number of you already have data warehouses out there, but is it a kind of collaborative space for data science? So I'm kind of passionate about data warehousing. I've been doing it for many, many years. And I feel that sometimes data warehouses have got a bad name, and we've gone off down this kind of data lake route and some of these other technologies, and forgotten that sometimes our data warehouse can actually be a valuable source of information for data science. Ooh. Okay, bear with me. Not sure how the clicker works. So first of all, let's just kind of talk about data science, right? So here, and there's many representations of this kind of thing that you'll find on the internet and what the process is for data science or the data science lifecycle. And I think from a data warehousing perspective, there are areas in this cycle that data warehouses can really play their part. So the first part is in data transformation. So there's a lot of aspects to data science that require you to source in lots of different data sets, merge those data sets together, do some transformation on it, some what's called feature engineering from a data science point of view, so that you can get the data into a format that you can then start doing your predictive modeling exercise. And once you've done that predictive modeling and you've decided that you've got a good model and something that you want to deploy, you've then got to work out how do I get that into some kind of production context so that it's actually adding value to my business. And generally that requires taking all the transformations that you did in the modeling stage and working out how to replay those in a pipeline that runs in some kind of production process. So this kind of productionizing work that a data scientist has done and then passes maybe to a data engineer. For some of these new industry terms. So yeah, so feature engineering. What's feature engineering? It's kind of the process that we go through as data scientists in order to pull and distill raw data sets together in order to develop predictive models. We generally need the data in a particular specific format to feed into these modeling tools or modeling algorithms. So we need square data, columns and rows, and we need a row for everything that we want to put a prediction on. But coming up with features is generally seen to be difficult, it's time-consuming, and it requires business expertise or domain knowledge of the particular area that you're trying to build that model for. And so Professor Andrew Ng, who's a Stanford University lecturer in the kind of machine learning and AI space, kind of says, look, feature engineering is really the challenge around machine learning. Getting a good data set to feed into the model is the majority of the effort and work. And this is kind of just something that I hear regularly when I talk to customers, but I thought it was kind of funny when I found it on the internet. So data scientists spend 80% of their time preparing and cleaning data, ready for predictive modeling, and the other 20% of their time complaining about preparing and cleaning data, right? So how can we solve that problem? Well, data warehouses, what are they? They're a source of, hopefully, clean, pre-prepared data that we can use in the data science process. So, you know, that's what are some of the challenges that we face when we do this task, this feature engineering task to prepare data for data science? So we might be sourcing data from inside our data warehouse, inside our organization, into the data warehouse. We might also have external data sets that we're trying to bring in as well to enrich our own data within the organization. So a classic example of that might be weather data that's useful to help me in predicting seasonality of sales for barbecue food, for example. Generally, the data will be stored at the wrong level. It might be summarized too high a level, or it might be too detailed. But again, not at the level I need it at for modeling. We talked about this in one of the panel sessions earlier this afternoon, that data quality and master data management and governance is also very important in this, and that we need to make sure that the data's in the right kind of shape and clean enough to use for data science. And any new data that's coming in, we want to constantly be updating our features. So quite a lot of the features that you'll use in machine learning and data science will be temporal. What do I mean by that? I mean, it's like rolling, right? So it's what's the spend in the last 30 days? Well, that's something that I have to calculate every day, right? And I need processes that do that if I want to use that as a feature in my model. And then there are some very standard processes that I need to go through to get my data into a format that I can actually feed into the model. So if I've got very high range of values in one column and a much smaller range of values in another, then that's going to disproportionately affect my model. And so I need to standardize all my values across like a specific range. So like between 0 and 100 or minus 100 and 100. So all my data is at the same level. So some of the other aspects from an operational perspective is we often hear reproducibility. So how do I, if the regulator comes after me for this credit risk model that I calculated last month when I've gone bust, how do I replay that model and get the same result that I got 30 days ago when I ran the model? So for that, I need to persist the data and be able to go back to data as was and guarantee it's data as was when I built the model, quite often requiring multiple copies of the data that are used as input into each model. Talked about the deployment problem of kind of replaying the work that the data scientist's done in some kind of production system. And then the other big problem and challenge that I see is reuse. So data scientists tend to work on their own local machines or somewhat isolated in the work that they do, and there's very limited awareness of what other data scientists are doing, and maybe they're generating some features that would be very useful for my model. And so there's no collaboration or very limited collaboration and sharing of work. So net, the reverse of that, what are the desired capabilities that I might like in a system to help make the data science process more efficient? So I think they come in kind of three categories. The first is around discovery and sharing. So back to my point earlier of reuse, if I can see and have visibility into work that's been done before, generating features, doing this heavy lifting work to generate data that's useful for modeling, then surely that would be useful if I've got it available for the next time I want to run a model, rather than have to redo that work. Equally, I might want to go out and discover and get access to, as efficiently as possible, external data sources that are not within my organization, so like that weather data. From a storage perspective, I want to, just in the same way as we do with business intelligence, where we create data sets that are useful for running business intelligence reports and dashboards, I want to create a repository or some kind of model of these features that promotes reuse, version control, and all of these kind of good data governance principles. And I want that to be flexible so that the data scientists can put the data in the shape that's right for the model that they're dealing with, the kind of modeling tool that they're dealing with. And then on the processing side of things, what we call feature engineering, generally this is quite compute-intensive work, but it's also very cyclical or peaky. And so I want to have access to compute that's at the right scale factor to get the work done, but I don't want to have to pay for it to be there all the time. I want to be able to switch it on and off easily. And I want to be able to work with lots of different tools. So data scientists generally like working with open source languages like Python and R and Spark or SQL. And so they want to be able to interact using their language, but with the data that's useful to their processing. And they generally want like a really rich feature set of functions. That's why they use languages like Python and R, because they can get packages that do particular things to enrich their data and get the data into the format they want. So let's just segue to Snowflake. and kind of what Snowflake is from a data warehousing perspective, and then we'll drill down into some of the capabilities in Snowflake and using a data warehouse for this data science process. So Snowflake is a cloud-only, born in the cloud data warehouse technology, designed to make use of the elasticity, the infinite storage capacity that you have with public cloud vendors. It's a SQL database, so if you're familiar with writing SQL and using products like SQL Server and Oracle and these kind of database products that have been around for a long time, you'll be familiar and find Snowflake easy to use. But because we run as a service, we optimize the system ourselves. You don't need to maintain it. It's a service level offering. So you don't have to worry about database upgrades. You don't have to worry about tuning and optimization. That's kind of done under the covers as part of the service. As I mentioned, it will handle effectively infinite scale of data because it's cloud-based. We're relying on the underlying storage of the cloud vendors, and it will support infinite compute. So one of the key things with Snowflake and the way it works is that we have a shared storage area, but you can spin up multiple what we call virtual warehouses. Think of those as compute of different scale factors, all operating against that shared data set. So in a data science context, that's really useful because it means that I can have either a team of data scientists with their own dedicated cluster, or if they're doing something really intensive, I can put a data scientist on his own in his own cluster of compute, but all accessing that shared data set. And as I mentioned earlier, we might have workloads where we're doing this one day and doing nothing the next. So I only want to pay for it when I actually use it. And final point, it's a cloud-based service where we provide data, or you load your data into. We have lots of customers doing that, and you'll see that one of the facilities that we provide is for you to be able to actively or live share data between different Snowflake customers, different Snowflake accounts, all within the same service. So for example, if I want to get access to some weather data, and there's a weather data service provider using Snowflake, they can share their table into my account. I get a live copy of that weather data, which I can use to enrich the modeling that I'm doing. And to that point, so let's think of this from the first step in the process that I had in the data science lifecycle. So the first step in the process is I've got some data maybe in my data warehouse or other systems in the business. I'm going to suck that into my data warehouse environment. But equally, I might want to get access to third-party data sets, other things that might be useful to help me build a better model. So if I'm building customer marketing, attribution models, I might want to get access to marketing data, demographic data, other data sources, the weather data I talked to earlier. And Snowflake Data Exchange gives us the ability, it's a public face for people to publish their data sets, basically. So you can go in as a Snowflake customer, you can search, you can look for data sets that might be useful. We have nearly 1,000, this was launched in the summer, we have already nearly 1,000 different data sets in there, and every week there's new data service providers, new organizations adding their data sets into here for it to be visible and shareable, either for free or with some commercial term behind it if it's obviously of value to you in your process. So the data provider gives you live access to the data. Effectively, it looks like a table or a set of tables in your account, which you can query and join to your other data sets. There's these different types of listings. So you can have a standard listing, which basically gives you immediate access, or a personalized listing where the provider gives you access to it, but it's refined and filtered down to the information you're specifically interested in. And it's instant, as I said, you just go in, click on it, and get it straight into your account without having to do a data loading process or something like that to get it into the account. So the next stage in the process is, okay, I've got my raw data in maybe tables in the data warehouse, but I need to get it into some format that I can feed into this data science modeling algorithm. And to do that, we're going to generate refined features. And we need to think about how do we actually store that. So we could just store it relationally, right? So for every, in this case, this is cars. I've got some different attributes related to cars. So I've got the number of cylinders, the horsepower, those kind of things. If I wanted to predict what MPG was, I could use those as input to my model to predict the MPG of a particular car. But I might want to derive additional features as well, so more calculated measures. And generally what ends up happening in this scenario is I end up with hundreds or even thousands of features in a table, in a very wide table, which can be unwieldy to deal with. So another method of handling that is to actually store it in what I call tall or stacked format, so where you basically have each feature stacked on top of each other. And now I only have a few columns and repeat the feature multiple times. That's quite efficient for processing in Snowflake, and we see a lot of customers using this particular method. And then finally, one of the other capabilities of Snowflake is it doesn't just support tabular or structured data sets, we also support semi-structured or hierarchical data sets. So file formats like JSON you can load into Snowflake, where you have a nested or kind of semi-structured data source. And that can be really, really interesting and useful for data science as well. So for example, if you're doing time series forecasting, maybe forecasting stock levels or something like that, generally you'll want to store your data in an array of intervals with a value per time interval. And this is an efficient way of storing that data. But the advantage of actually having your data in this feature repository is like it's shared, multiple people can access it, you can enrich it over time with new derived features and maintain it using kind of normal database processes, and you can store it efficiently, which is quite a nice way to work. So another aspect of Snowflake is something we call zero copy cloning. You can think of this as a way of snapshotting your data without actually physically copying your data. So I mentioned earlier that one of the things we need to do when we're running models, maybe if we're rebuilding the model on a daily basis or refreshing the model on a daily basis, is calculate and recalculate all my features and then use that to retrain the model. With Snowflake, you can take a clone every day of the data. Effectively, we just store the difference. A little bit like the way that code management tools like Git, version control tools, GitLab, and GitHub work. So it just stores the difference, not the actual full data set or the full script every time you push to Git. And the same is true of Snowflake. We just store the difference in the data between each snapshot. So it's a really efficient way of version controlling data. And then you can combine that with version control for your code so that when you come to run the model, you know exactly what snapshot it was that you used to build that model for that particular iteration. So I mentioned that kind of one of the processes we're going to want to do is get data in and ingested and continually transformed. And for that, Snowflake provides a few capabilities under this banner of continuous data pipelines. So to start off with, you can load data kind of streaming fashion into Snowflake. That might land in a staging table in the database. And then you can run through a number of SQL steps using something called streams and tasks to schedule the processing of that new data as it's landing. So this is where I would put my feature engineering, my SQL steps for transforming my data into features that I'm then going to use as input to the model. I can run this with a frequency down to a minute. So this will just pick up the change data as it's coming in, apply my feature transformations, and populate my feature repository table with those transformations to put into my model. So there are, as I mentioned, in Python and R, there are libraries for doing some of these kind of common transformations that we use in the machine learning process. So feature scaling was one of the things I mentioned. Well, these are all pretty simple maths and actually really easy to embed into SQL. Snowflake provides functions that allow you to do these kind of tasks so that when you query the database, you can get these particular feature transformations directly out of the database. So this is a bit like using Python or R to do this, but instead of doing it in a language, you're doing it in SQL instead. So we've transformed our data, we've stored it in a feature repository, and We've got this updating on a constant basis. We're snapshotting our data using this zero-copy cloning feature. Now we get to the point where we actually do the interesting stuff, which is running and building the models. So this is the bit that the data scientists actually enjoy doing, right? Not all that kind of plumbing that's gone beforehand. And for that, Snowflake has a few different capabilities. So you can pull the data out of the feature repository, so just select the data from the table, and pull it into these common tools that people like to use, so R and Python, Spark if you're using that. And then you do your training outside the database in those languages, on those environments. And then once you've got the model, there are ways of us actually doing the prediction inside the database. But we also have the ability to do some of the training in the database as well. So there are packages in R that will push the model training into the database as SQL operations. We provide some functions inside the database engine itself that will do that modeling as well for some simple models. And one of the nice things about Snowflake is it's got user-defined functions, so you can actually write your own models, your own code as well. And we quite commonly see customers, that works using JavaScript as a language. So we quite often see people bringing in JavaScript libraries with common machine learning models and using them inside the database engine to do their modeling. And the example here on the right-hand side, the kind of visualization that's, the animation that's spinning through here, that's a clustering or segmentation type model. It's called k-means. This is running inside the database using SQL, and then it's visualized with Tableau. And one of the other aspects to the way that we store the data, we allow you to run a query not just as of today or at this particular point in time, but you can run a query as of any other point in time in the data. So in this modeling process, every time I run segmentation, I'm refining the segmentation and narrowing down where these clusters are for the segmentation. Each of those is a SQL operation, so I can, with the visualization here, I can see how the clusters have started to conform or merge together as the operation is processed through. And then I mentioned in-database prediction or scoring. So that's another area that we can perform like the prediction, take the model, and actually productionize it in Snowflake. So I've got my data engineering pipeline that's being used to generate my data for training. I can take that exact same SQL pipeline, I can put it into a production scheduled process using Snowflake, and then at the end of it, I take the model that I've created in the modeling process, and I run my prediction. And get some kind of predictive output. Now, I might want to run that just on a single record, or I might want to run it on a batch of records and produce a set of predicted outputs in a table that other people are then going to look at and consume. And so I talked about the Snowflake Data Exchange, the public data exchange, where everybody's got the ability to go and look at these public data sets that have been published within the data exchange. So something else that we're working on at the moment, we announced last week, is a private data exchange. So think of this as, I like the idea of having a marketplace for data, but I don't want everybody to see what I'm putting into that marketplace. It's more to a closed audience. That could be just because I want to share specific data sets in a specific format internally within my organization, maybe between different operating companies in the same company, or different departments. This could be a way of publishing those data sets to share between those parts of an organization internally, like marketing or finance, etc. But equally, I might want to actually share this analytic data output to third parties. So a good example of this is in retail. So I've got some store sales, stock data. As a retailer, I can see the movements of stock, and I want to allow my suppliers to see that stock movement data, but not just the movement data. I want to show them when I think they're going to be out of stock based on my prediction, which they can't see. They're obviously supplying stock based on what they think the sales is. Might not be that accurate. I can provide them with more insight. I can get better shelf availability because I can give them direct access to my prediction through this private data exchange that I'll give them access to. So just to kind of talk to a customer example, so Uniper is a customer of ours in the energy utility sector. Been using Snowflake for a little while now, over a year, and have used it for their data warehouse and for their data lake. They're loading data from many, many sources, and also bringing in that third-party data that I mentioned. So you can imagine in the energy business, it is very seasonal, it's very affected by weather. So if I can bring in that kind of data, third-party data, then I can make my predictions more accurate. So this is their energy prediction or their demand curve for energy requirement. And they can then try and match to that with their own production, and then obviously buying third-party production from other people. And they use Snowflake to do these kind of different steps that I've talked about, feeding that into the modeling process. So many of our customers use Snowflake directly for data science. We're kind of known as a data warehouse vendor, but hopefully you'll have seen through this session that there are a number of capabilities in the platform that allow you to collaborate and share data in a valuable way from a data science point of view. We had a conference back in the summer where we had a whole channel dedicated to data science, and this is just some of the sessions that were run in that event. In London on the 3rd of October, we've got a day summit, which you're more than welcome to join us for. You can sign up on our website. We'll be covering some of these different things at that event. So really be happy to, we've got a stand outside, be really happy to see you if this has been of any interest or you want to come and talk to us with any questions. I think I'm pretty much out of time, so I don't think I've got time for questions unless...
Right.
Okay, thanks very much, everybody.